People can understand this.
Well, but we have not been able to find the lateral surface area proof of the formula, so you're claiming that you found it?
Yeah.
Okay, let's see how I've done it.
Okay, if this length here is L, and if
So that's called a slanting length?
I don't know. It's just L, okay? And if this length is the middle, if this length is the radius of this circle, R, okay? Then this entire length, this circle's circumference, okay, it's a badly drawn circle, its circumference is 2 pi r, right? Now, if we ignore the circle, but remember the circumference of it, just for now, okay? What we have here is this. We look at the cone, okay? After we look at the cone,
Make it quick because people are impatient.
okay. So after we look at the cone, we can spread out the cone. Spreading out the cone gives something like this, where this length here is the circumference from here, okay? So this length would be 2 pi r, and this length over here would be L. Now, if we look at this carefully, this is just part of a circle, where this part is 2 pi r, okay? And since L would be the radius of this larger circle that we do not see here, it's just part of a circle, this entire circumference would be 2 pi L, okay?
So
Now-
you mean the R is smaller than L?
Yes, R is much smaller than L. So we're only dealing with this part, and this part is what makes up the cone. Lateral surface area is just,
An extension.
no, it's just this entire surface area excluding this circle.
Right.
Okay? So, now that we've excluded the circle, we just need to find this area of this, okay? So, to find that, we need to use the formula for sector area, which is half r squared. This r and this r are not the same thing. This r just represents the
Then why didn't you just write radius? Half radius squared.
radius, half
My
radius
videos
squared.
can't even see your handwriting.
Whatever. This says radius. Half radius squared, okay? Times what again? Times theta in radians. Okay, theta in radians. That's why I'm going to put a small r under it. After that, if this part is this area right here, we need to find what theta is, which would be this much, okay? So we use one formula, which we already have, the arc length formula, arc length, because we already have part of the length, which would be 2 pi r, which is the arc length. And we also have the radius of the circle, which is L. So we already have for the formula of the arc length. The formula for the arc length is sector area is equal to radius times times theta in radians. Okay? So our objective is to find theta from this. So we already know the sector length, which is 2 pi r. We also have the radius, which is L, okay, because this part is L, it's part of the circle. And we do not know what the theta in radians is. Theta in radians, okay? So now we can just find that the theta in radians is equal to 2 pi r over L.
Where did you find that from?
I just divided both sides by L,
Okay.
okay? So that would give us the theta in radians for this this angle right here. Okay. Now, using this previous equation of sector area is equal to
Radius squared.
half of radius squared. Remember, the radius itself is L, so L squared times theta in radians. We already figured out that theta in radians is 2 pi r over L. So you write 2 pi r over L. Now, L squared is on the numerator, so that gives us L. 2's on the denominator, 2's on the numerator, so that just becomes 1. So after just like simplifying it by multiplying it all together, we find that 1, because that turns into 1, times L, that turns into
Oh, you
L.
don't have to do all that.
Yeah, I know. And that turns into pi r. So the area for just the cone part, not the actual bottom circle, gives us pi r L.
Oh, brilliant, because I didn't find any proof of the lateral area of a cone online anywhere. They're giving different kinds, and they're using the lateral surface area formula to begin with to find a frustum or something, but they never proved this. So this is an excellent proof. You just proved it by thinking for what? Half an hour, 20 minutes? You look like Isaac Newton, by the way.
No.
Yeah, with that hair. You should have a haircut. He didn't look very good with that hair. When are you having a haircut?
Huh?
Yeah, never mind. That's not part of the math. Yeah.
Close it.